Okay, so good afternoon, Lamai. So from today, we are going to start a new series of programming lesson. Okay, new video series of programming lesson, and all the classes will be held on Zoom online, and I will upload the video to the YouTube as well. Okay, so you can either join the live classroom, okay, or you can watch the YouTube video after the classroom. So whatever my suggestion is, join the live session because here you can interact with me, but when you are watching the video, it's really you become very lazy. Okay, it's not very interactive. So please join the live video if you really want to learn things. Okay, so Lamai, from today we are going to start Python lesson. Now, programming lesson is the 9th lesson of our syllabus. Okay, I think you know about our syllabus, and I believe students here are from 2024 batch or 2025 batch. For the 2026 batch, I think this is not the right time to study Python. But if you are a 2025 or 2024 student, then this is the ideal time. But if you are a 2024 student, you might have to, you should have start studying Python at least couple of months back. But if you are a 2025 student, now this is the ideal time to start learning Python, because you have almost 1 year to face your exam, and you have enough time to study all the theories of programming languages, and also you have some time to practice these codes as well. Okay, now if you are a 2025 student, now this is the ideal time to start learning Python. Okay, so Lamai, raise your hand. Okay, raise your hand if you know any programming language. Please raise your hand if you know any programming language. So there might be students who know Python already. There might be some students who know some other programming languages other than Python. Okay, so raise your hand. So it might be Python. Python is okay. So if you know Python, please raise your hand. It seems no one knows Python. Okay, so Sachin knows some Python. So I believe you know some of the Python. So anyway, Lamai, I'm going to start from the very scratch. Okay, from the scratch, I'm going to teach the Python lessons. So the golden question is, what's the programming language? Okay, before start coding in Python, Lamai, we have to understand. We have to have a better image. Okay, we have to have a better image. What's the programming language? Then only we can understand Python, Lamai. Okay, before start learning Python, we have to have a proper knowledge. What's the programming language? Okay, how programming languages are working? Why people build those programming languages? We have to have a better understanding about those things. Then only we can move into Python. Okay, so golden question today. Okay, what's the programming language? Raise your hand if you have a better what we call better description or a better definition for what's the programming language. Okay, the lamest definition that you can have is the programming language is a language that you use to communicate with a computer. Okay, that's the answer. Okay, that's an answer. But for O-level students, so if you are a A-level student, you have to have a better answer. Okay, now, that's not incorrect. Okay, that's not completely incorrect. But if you have, since you are A-level students, you have to have a better definition. Okay, you have to have a better definition. But programming language is a language. Okay, it's not incorrect. It's a language that we use to communicate with computers, like Sinhala, Tamil, or English that we use as humans. We use those languages to communicate with our friends. Not programming language is a language that we use to communicate with our computer, but that's a very lame answer. You have to have a better answer for that as A-level students. Okay, that's the only thing that I'm worried about. So raise your hand if you have a better definition. Okay, if you have a good definition that you can say to me, what's the programming language? Raise your hand. So if you have answer, you can put in the chat, Lamai, because I have I'm not allowing you to turn on mics right now, because in other classes when I'm allowing students to turn on their mics, they used to turn on their mic, and we can know what's the problem at their houses and what they are going to eat for their dinner. We can know everything. So here in this class, I don't need to do that. So I'm not allowing you to turn on your mic. But if you have any question or if you have any answers, Lama, you can just put in the chat. Okay, I'm going to read those things. So yes, still I can see the chat. So if you have any answers, please put in the chat. Okay. Can anyone say what's the programming language? Okay. I think Sachin knows some Python. So Sachin, could you answer this question? What's the programming language? Now, this is the golden question for today, Lama. I'm going to ask a couple of golden questions. Okay, series of golden questions within today. And also, Lama, one another thing. Today only we are going to use this setup. Okay, this whiteboard setup. From the next episode, we are moving to our computer screen sharing setup. Okay, somehow, Lama, I also doing other classes in both setups. but I kind of love this setup because you can see me properly, and I'm having this whiteboard environment, and it's just kind of it's very familiar for us for education wise. We are very familiar with these whiteboard things and other stuffs. But when it's come to programming like things, Lama, it's better if we can share our screen and do everything there. So if you watch the previous videos that I did for single medium students, so you can see the first video also I did in the computer environment, okay, the screen sharing environment. But from next episode we will move into the computer setup, okay, screen sharing environment. But only today we will use the whiteboard setup. Okay, now again we are back to we have answer a set of instruction given to computer to accomplish a task. Superb. Now this is the definition for a program, Puta. Okay, set of instruction given to a computer to accomplish a task. Now that's the definition for program. That's not the exact definition for programming language. Okay, so somehow that's the answer for the next question, the next golden question that I'm going to ask you. Okay, now that's the answer. So I will leave that there for now. Can anyone tell me what's a programming language? I really hope, Lama, you can interact with me. I really appreciate if you can interact with me. That's the whole reason of doing a live class now. So otherwise I can just record the video and upload to YouTube, but that's very lazy. Also I don't like to record videos myself because it's very lazy. If I'm not interact with you, it's become very it's not much interesting. So okay, let's move into the lesson then, Lama. So okay, I'll explain you now. Okay, somehow again I have to come back to the Sachin's answer. So now why we are using computers? Okay, now we let's keep that question aside for now. Okay, now why we are buying computers? So why we are using computers? That's the next question, because I didn't got any answers for a definition of programming language. That's why I'm asking this question. Now this is the question for the second lesson, the hardware lesson. Okay, let's start from there, Lamai. So I said I'm going to start from the scratch. So we have to have that idea. Okay, why we are buying computers? Okay, as human, why we are buying computers? Okay, I'll give the answer for this one. So basically, we are buying computers to make our lives easier, right? I think you agree with me in this answer. Basically, we buy computers to make our lives easy. That's the most abstract answer that we can give for this question, Lamai. Okay, that's the most abstract answer that we can provide. Now, the next question is, how computers make our lives easier? Okay, now I have my computer here. Now, how this computer makes our lives easier? Okay, I have a washing machine in my home, Lamai. So how the washing machine going to make my lives easier? Is it going to collect all the dirty clothes in my house and it's going to wash those clothes himself? No, washing machine is not going to do that. Okay, washing machine is not programmed, or washing machine is not built to do that. Okay, so how computers help to make our lives easier? Okay, how computers make our lives easier? Using softwares. Okay, when we are using softwares, computers make our lives easier. Now we have this Zoom software. Since we are having this Zoom software, I don't have to come to a physical classroom. Okay, I don't have to watch. I don't have to record these videos into CDs and distribute within you. Okay? So I don't have to do these stuff because now I have this Zoom software. So I can do this classroom remotely. Okay, so you can also watch the classroom in a remote place, Lamai. Okay, that's how software is making our lives easier. If we think about a software like Photoshop, before we are having softwares like Photoshop, Lamai, were we able to actually edit our photos? No. If we capture a photo into a hard copy, now I'm not sure you guys have seen those aesthetic photos that we took from real cameras. I think that's the word for that. My vocabulary is not much good, but I think those are real cameras. So we are using some Polaroid reels or whatever. So I don't know the exact jargon for that. So we use some hard copy to capture the image, and we print it into a photo paper. Okay, that's how we capture photos. But before, when we move into digital photos, nowadays photos are stored inside our computers in a digital way only, using 1 and zeros. Photos are stored in our computer. But But before that era, okay, before that era, when we are having only hard copies, how you think we edit our photos? Okay, if we definitely need to, like let's say we are eager to edit our photo, then we have to use brushes and pencil like things, right? Otherwise, there's no way to edit our photos. But now, since our photos are in a digital media, and since we are having softwares like Photoshop and Canva, we have a number of photo editing softwares nowadays. Using these softwares, we can edit our photos. Now that has made our life easier. Okay, we don't have to use hardware tools to edit our photos. Okay, so somehow if we are using those brushes and pens like tools to edit our photo, if we did something wrong, or if we do something wrong, there's no going back. Okay, there's no going back. But when you're using Photoshop like software, if we do anything wrong, then we just have to Control Z. Okay, we just have to undo. Okay, then it will bring to the last snapshot of that particular program. Okay, that's how softwares make our lives easier. Okay, so this is not actual thing to discuss with A-level students. Okay, you have the idea. Okay, how softwares are making lives easier. Now, what is the software? Okay, we also using the program, the word program to mention a software. Software or program, both are equal names. Okay, now what is a program? Yeah, I already got the answer for that. So somehow I think Sachin has put that in a private chat. So other two people, you have a chance to tell your answer. Okay, what is the software or what is the program? Can someone put your answer in the chat? Okay, please interact with me, Lamai. Then this lesson become very interesting to you if you are being very interactive with me. So can someone put your answer on the chat? Okay. What's the program? Okay. Seems you are not still interacting with the classroom, but anyway, okay, I'll explain you. Now, when it's come to a computer program, okay, when it's come to a computer program is nothing but a set of instructions. Okay, we got the answer. So I am completely new to this lesson, sir. Super. No worries, Pratap. No worries. If you are completely new, I am starting from this scratch. Okay, I have started from this scratch. Now, this first couple of things that I am teaching you, those are actually related to the second lesson, Lamai. Okay, now second lesson or the hardware lesson is the most underrated lesson in our syllabus, Lamai. So when I'm teaching my single medium student, now this is the first time that I'm doing English medium class to any students, okay, any batch. This is the first time that I'm doing an English medium class. But when I'm doing classes to single medium students, especially 2025 students, that's where I started my first theory class. The most of the time I spend with them is to teach them the second lesson or the hardware lesson. That's the most underrated lesson in our syllabus. You have to put more and more effort to understand the second lesson, when it's come to the von Neumann architecture and fetch, decode, execute cycle. These are the actual thing which happen inside the computer. If you understand these stuff properly, then you can understand the programming language. All other stuff, it's become very easier to understand. First, you have to have a good knowledge about how our computer physically works. That's what we teach in the second lesson. But with the competition that we are having in the A level now, most of students are ignoring this lesson because the second lesson, because it's not very prioritized in the A level paper. Okay, even though we know the second lesson completely, we can get only 2 to 3 marks from MCQ. Okay, so because of that, not only students but also teachers are ignoring teach them. Also, there are only few teachers who can teach that lesson because most of them are not software engineers, so you don't have much knowledge in that area. Okay, so students and teachers both are ignoring teaching those things. But here I am saying that's the most underrated and one of the most important lesson in our syllabus. Okay, let's talk about those things later, Lamai. So however, let's move into our first question. Now, when it's come to a computer program is nothing but a set of instruction. Okay, set of instruction that we have written in a way that computer understand in order to accomplish some task. Okay, computer program is nothing but a set of instruction that's written in a way that computer can understand, not human can understand. Okay, if that particular program, if human are capable of understand that particular program, then it is a human program. It's not a computer program. Okay. Now, what are the human programs, Lamai? We have seen a set of instructions that written in a way that human can understand, and we are going to execute those instructions, and we are going to get some output. Those are human programs. Okay. Have you ever prepared Maggi noodles, Lamai? Raise your hand if you have prepared the Maggi noodles packet in your entire life. Please raise your hand. If you have prepared a 2 minutes Maggi noodles packet in your entire life, please raise your hand. Now, I was used to do that when we are in the boarding place. Okay? I graduated from Monato University. When we were in the university, we were used to get some late night stuffs using Maggi noodles. Okay. So Sachin has prepared noodles packet in his life. So when we buy a noodles packet from the market, Lamai, okay, when we buy a noodles packet from market, you can see this screen, right? Okay, I'm going to this word noodles. Okay, fast food. It's a fast food noodles, Lamai. Okay. When we buy a noodles packet from the market, in the backside of the packet, you can see set of instruction written in a way that human can understand. Okay, like boil some water and cook this Maggi packet, noodles packet under like 2 minutes in boiling water, and add all the ingredients that we're having in those sachet packets inside the Maggi noodles packet. Okay, put them to the noodles, and then wait until like 1 minute to get prepared, and then you can serve. Okay, then you can serve. Now these instructions are written on the backside of the packet. Now what we do as people, now this one is Lamai, first thing that we have to understand. Now this is human readable, or human can understand this particular set of instructions. Because of that, we call this a human program or a people's program. Okay, there's no such word, Lamai. Okay, there's no such word, but here I'm only telling to understand this stuff. Okay, we can call this a human program. Why? Human can understand this program or the set of instruction written in the Maggi packet. Human can understand, and also some human is going to execute these instructions, Lamai. Not a processor. A human is going to execute these instructions. Okay, so because of that, we can tell this a human program. Yeah, I'm going to write that word. It is not existing. Okay, this is a human program. Okay, now this is set of instructions. Okay, this is nothing but a set of instruction. Set of instructions. This is set of instruction which is written in a way that human can understand. Okay, okay, I'll add that part as well. Okay. Let me add that part as well. Human readable. I think you can see what I'm writing here, right? Okay, now this program is human readable and human understandable. Okay, also some human is going to execute these instructions, Lamai. Okay, not a computer or a machine is going to execute these set of instructions. Only a human is going to execute these instructions, Lamai. Okay, so we can call this a human program. Now when it's come to a computer program, Lamai, this is same. Okay, the philosophy is same, Lamai. Computer program is a set of instructions. Now here I am drawing a computer program. Okay, now this is a computer program. Here it is written in a way that computer can understand. Okay, now these instructions only computer can understand, Lamai. Okay, there is a set of instructions. Okay, this is also a set of instruction, Lamai. But now this one is computer understandable, only computer understandable. Okay, now let me write here. This is what? A computer program. Okay, now this is a computer program, and this is computer readable. This is computer readable or a machine readable. Okay, we can say both words, machine readable or a computer readable. Only a computer can understand these and execute these instructions. Okay, so Now this program is going to be executed by a human. Okay, let me draw some human here. Now this man or a woman, okay, this person is going to execute this instruction. When he execute this instruction, he will have some output line. Okay, he has some input and he has some he executes some program, and after executing that program he will have some output. Okay, he will have some output, which is the output a delicious dish of noodles. Okay, he will have a delicious dish of noodles that he can consume. What are the inputs? The Maggi noodles and those ingredients that we have in the sachet packets. Okay, those are the inputs, and he executes some program with these inputs, and then he will have some output, which is the consumable noodles. Eatable, is there such word? I don't know. Eatable is a proper word or not. So, however, at the end he will have some noodles that he can eat. Okay, computer program is very similar to that, Lamai. Okay, we have this instruction, and who is going to execute this program, Lamai? Okay, now who is going to execute this? Who will execute this instruction? Okay, now in the second lesson, if you have learned the second lesson, Lamai, which is the hardware lesson, you know who's the part, what is the part inside the computer is going to execute instruction. Okay, who is going to execute this instruction, Lamai? When we are learning, when we are studying about the von Neumann architecture, we study that we learn that there are a couple of components inside of a computer. The first one is CPU, and the second one is main memory, and there will be inputs and outputs as well in order to work a proper program. Okay, now these things are there. Now, which component is responsible to execute instructions, Lamai? Superb. Processor. Processor is the component which is responsible of executing these programs, Lamai. Or the CPU. Lamai, give me a second. I'm getting a call. Okay, Lamai. I think I'm still visible and audible to you because I got some call. That's the phone that I'm actually used to record this video as well. So I think still I'm audible and visible to you. So Lamai, please raise your hand if I'm audible and visible to you. Still audible and visible. Super, thanks. Okay, now processor is the element or the component, Lamai, who is going to execute these instructions. Now when we say this is computer readable or a machine readable, Lamai, we are actually saying is this program is processor readable. Okay, processor readable or CPU readable. Okay, that's what we are telling here when we are explaining what's a computer program. We told that a computer program is nothing but set of instruction which is written in a way that computer can understand. Okay, we said that. So when we actually saying computer can understand, we are talking about the CPU, Lamai. CPU can understand because CPU is the one who is going to execute these instructions. Okay, we learned in the second lesson, we learned how the CPU going to execute this instruction. We learned something like fetch, decode, execute cycle. First he will fetch this instruction from the memory into the CPU, then he will decode it, then he will after decoding he will have operator and operand. Then when he knows the operator, he can pass that instruction to that particular operator. Then he's going to execute this instruction. Okay, we'll learn those things in the second lesson, Lamai. Okay, now we know how CPU going to execute these things. So if you are really interested to learn those things again, the second lesson specifically, I will do another session. So please let me know if you are interested to learn the hardware stuff as well. Okay, now somehow CPU is the person who's going to execute this program, Lamai. So this set of instructions. Okay, we call this a computer program. Okay, we call this a computer program. Now I think the fourth question, right? Fourth question, I'm going to ask you. This is another golden question, Lamai. Okay, this is another golden question. Now my question is, can human, okay, can human, now Lamai, just wait a minute for that question. Now I say, now computer program is nothing. Now we know these computer programs are going to make our lives easier. Okay, when we have computer programs, only people will buy computers. If you don't have computer softwares, people are not going to buy computers. Okay, I'm getting another call. Okay, Lamai, so when we what I was talking about, so I was talking about this program, okay. People will buy computers only softwares are available, only softwares are available, then only people will buy computers, otherwise people, they don't have any reason to buy computers. So now here we have softwares. What software does? Software basically help to make our lives easier, okay. Now since we know softwares can make our lives easier, we also might want to make our own softwares, because we know that softwares can make our lives easier. So if we have some scenario that we know now, okay, if I build software like this, it will make some people's life easier, then they will going to buy my software and I will get some money, okay. With that mindset, we are going to build some software, okay. Now if we want to build some software, what we have to do? We have to write this set of instructions. That's what we have to do. If we want to build our own computer program, what we have to do? Nothing but write this set of instructions, okay. Software is nothing but set of instructions which is written in a way that computer can understand. So if we want to build some computer, what we have to do is write this set of instructions. If we can write this instruction in a way that computers can understand, then we can build softwares. Now my question is, can human understand this set of instruction? Okay. Now this is if we write a program that computer can understand, this has to be written in a language some computers can understand, or machines can understand. Now what's the language that machines understand? Okay, it's the machine language, it's the machine language. Okay. Machine language. This is the language that computers understand, okay. What are the languages that human understand, Those are human languages, or we call natural languages. Okay, natural languages or human languages. When it comes to natural languages, there are many examples, Sinhala, English, Tamil. Likewise, we have many examples. Japanese might be English or whatever. Human languages are there. Okay, there are many examples. When it comes to machine language, also we have many examples. Okay, there are different instructions targeted, but we are not going to talk about these things right now because it's not very important to you. But you have to know this thing. Now if we write some program that computer can understand, it should be written in a machine language. Okay, machine language is nothing but 10. Okay, machine language is nothing but something written in a 10. Okay, 10. That part is enough for you right now. Okay, up to here that part is enough. So if we want to create some computer program, we have to write these instructions, and we should know machine language. Machine language is what? A way that we can tell computers, okay, do this thing and these things in 1 and 0. Okay, that's the machine language. If we know machine language, then we can directly tell computers, okay, do this thing and these things. We can tell computers because we know machine language. Now my question is, can people understand this machine language? Do people know this machine language? Raise your hand if you believe people know this machine language. Raise your hand if you believe that people know this machine language. Okay, raise your hand, Lamai. If you think people know this machine language, raise your hand. Okay, no answers. Okay, then raise your hand if you don't believe that people know this machine language. Raise your hand if you think people don't know machine language. You have to raise your hand to one of the answers, Lamai. Okay, raise your hand if you think people don't know machine language. Please be interact with me, otherwise this become very lazy. Okay? It has to be a very interesting class. Okay, you are learning very interesting stuff. So raise your hand if you believe that people don't know machine language. Okay, you have 1 hand, 2 hand. John, what do you think? Okay, do you believe people know this machine language? Okay, now we got a couple of hands using people don't know machine language. Now my question is, who built these computers, Lamai? Who built these computers and who built these languages? Because aliens did that. Did aliens build computers for us? If not aliens, then it be humans. Okay. So now in the second lesson, in computer history lesson, you learn complete what do we call history of our computers. Okay, people build these computers lamai. Okay, people build these computers, humans build these computers. Now if human can't understand this, then how they build this lamai? Okay, they can't say that they were doing some they were just collecting some transistors and other electronic components and suddenly okay the computer appeared. We can't say that lamai. Okay, magically computers appear, we can't say that. Okay, they build this in a theoretical way lamai. Okay, they did a lot of researches and then they build these computers. Okay, now the answer for that question is lamai, people know machine language. Okay, people know machine language and people can understand machine language, but the problem is it's very inefficient lamai. When people are working with this machine language, it's very inefficient. Only few number of people in the entire world can understand this as well lamai. Okay, people can understand this, but it's very difficult to understand this machine language lamai. Only few people in the entire world know this machine language related stuff. Okay, that's the problem lamai. Then if it is the case, what's the problem like? Okay, now at least few people know this machine language. Now what's the problem? Now they are the only people who can build softwares, because they are the only people who know how to write instructions that a way computer can understand me. Okay, that's the problem lamai. If there are only few people who knows how to write programs in a way that computer can understand, they are the only people who can build softwares. But nowadays, there are a lot of software engineers in the country lamai. Even in our country, there are a number of software engineers nowadays, and the most competitive industry to join as a fresher is the software industry nowadays. Okay, so people know this machine language lamai, but the thing is it's very difficult to learn and understand. Okay, there are some people who understand this machine language lamai. Okay, there are some people who understand this machine language. Now even though we say this is 1-0 lamai, there's a one level high abstraction for this. Now if I write a computer program in the machine language, I can write in English letters as well lamai. Now this is, even though this is 1 and 0, we can come to a one level abstraction or a one level higher, and we can see these programming languages, not programming languages, we can look at these programs in assembly language. Okay, and now if we write this program in assembly language, it will be something like this. Okay, like load A 108 and then load B 109 and add, and not add, I'll use sum A B, and I write ACC and store ACC 110 and exit 0. Okay, this is the program lamai. Now this is a program which is written in the machine language. Okay, when actually this program is getting executed lamai, this will also converted into 1 and 0s. Now I have come one level higher. Okay, now we are in the assembly language level. Okay, if we write a computer program in assembly language, it will be like this. Okay, there are some instructions, but this is also very difficult for people to understand. Okay, this is also very difficult to understand for people. Okay, this is the structure of machine code. Okay, machine language code. Now I explain what's the problem lamai. Okay, now if we are writing softwares in machine language, the problem is very difficult to study this machine language, very difficult to understand this machine language. Only there are few people who can understand this machine language properly, and if it is the case lamai, they are the only people who can write softwares for us. Okay, then that's the problem. So people decided lamai. Okay, then people decided, okay, now as the advent of the development of the technology, okay, now we have very powerful computers. Okay, now we are having very powerful computers. So if there are only few people who knows to write programs, then it's become very inefficient lamai. Even though we build supercomputers, we build more and more computers, there will not be many people to write softwares. Okay, even though we build more and more computers, there won't be many people who's capable of writing these softwares. That's the problem that we have. Okay, so they decided, okay, now the problem is people can't understand these computer programs or the machine language, not computer programs. People can't understand this machine language. But other problem is computer can't understand natural languages. Okay, now computer can't. Now if I say my computer, if computer can understand what I am saying, okay, then I can instruct my computer to do anything. Okay, if I want to create a software that will do the whole classroom for me, then it's become very easy. I have to lay in the bed and I just say my computer, okay, teach Python lesson today for my students. Okay, then some computer software are going to teach you, and I don't have to do anything. If computer understand the exact things that I'm saying. But the problem is computers are not built in that they can't understand the natural language. Or a human, what a human says, computer can't understand. And the other problem that we having is people can't understand these computer programs. Okay, let me draw this lamai. The problem that we having is, now we have people here, or humans, and we have computers here. Okay. We are having some computers here. Computer is not very beautiful, so let me draw that again for you. Now we have these computers. Okay, we have these computers and we have this human in this side. Okay, now humans know what? Humans know natural languages. They know natural languages, and computers know what? Computers know machine language. Computer knows the machine language, the human knows the natural language, the computer knows machine language, and people know the natural languages. And the problem is human can't understand the machine language and computers can't understand the natural language. That's the problem that we are having. It's like I have some friend who's from China, and he knows only the Mandarin, and I know only Sinhala, and there's no way that we can communicate because I don't know Mandarin, he don't know Sinhala language. So there is no way that we can communicate. Okay, that's the same thing that we are that's happening here, Lamai. That's the same thing. Okay, these two entities having some language barrier. Okay, they can't communicate. Now, if I have a friend like that, Lamai, like let's say a friend from China come to Sri Lanka, and I want to have a chat with him. Okay, now I don't know Mandarin. In the same way, he don't know Sinhala. So what we can do? We have to come to some middle ground, Lamai. Okay, we have to come to some middle ground, and we have to use some another language. Or either I can learn Chinese. I can learn Mandarin. That's one option. Or he can learn Sinhala. That's another option. But learning Mandarin is very hard, Lamai, very difficult. Okay, you know that. But learning Sinhala is also very difficult, Lamai, because these languages are very very complex languages. But when it comes to English, it's very easy. Okay, that's what we are going to do now. I'm going to study English, and my Chinese friend, he will study some English. Then we can communicate. Okay, we do the same thing here, Lamai. Okay, in programming world or the computer science world, we do the same thing. Now, computer can't understand natural languages, but human can't understand machine languages. Now, what we are going to do? We create something called programming languages. Okay, we create something called okay, I'll write that name below the box. We create something that's not very beautiful. Just ignore that behavior alone. Okay. I have some problems with my writing. Okay, now what is this? This is programming language. Okay, now this is programming language. Now computers know only machine language, humans know only natural languages. Now here we have programming languages. Now raise your hand, Lama, if you believe now computers can understand programming languages. Raise your hand if you believe that computers can understand programming languages. Raise your hand. Okay, raise your hand if you think computers know programming languages. Okay, we have one hand, and okay, we have two hands. Okay, raise your hand if you think that human can understand programming languages. Human knows programming languages. Raise your hand. Raise your hand if you think people or human know programming languages. Raise your hand. Okay, now we have a couple of fans. Okay, Lamai, then let's okay have okay, all agree with me. Okay, now you think people knows programming languages, so Lamai, we can end our session now because you know programming languages, ni. Okay, you know programming languages, so we can end our session, right? Now this is what is the topic today? Okay, it's programming. Now you already know programming. You believe people know programming languages, right? So I think we can end the session, right? Isn't it? No, Lamai. People don't know programming languages. Why do you think we know that? Okay, we don't know that. The same way, Lamai, computers also don't know programming languages. Okay, that's the beauty of this Lamai. That's the beauty of this program, this lesson. Okay, now as humans, we wanted to create some computer programs. Okay, as humans, we wanted to create some computer programs, but the problem is we don't know language of computers, which is the machine language, and computers don't know the language of people or a human, which is the natural language. Then we created another language which we both don't know. Okay, we created another language which we both don't know. Even computers don't know programming languages, and human don't know them. Okay, human don't know programming languages. That's why you have that's the whole reason you are being in this classroom, Mama. Okay, because you don't know programming languages. Okay, when I was in your age, I also didn't know programming languages. Okay, so we have to find out some way. We did build programming languages, okay. We have built programming languages. Now we have to find some way that both parties can understand the programming languages. We have to do some things for that. Okay. So now Lamai, what humans do in order to understand programming languages? As people, what we do to understand programming languages? Okay. We study programming languages, right? We get educated. Okay, we go to live classrooms, or we read books, or we watch YouTube videos, or we read documentations, or we do some practicals. In a couple of ways, we are studying programming languages, okay? We are getting educated. So now what's the mechanism that we use to get familiar with programming languages? Education. Okay. We are getting educated. Then only we know programming languages, right? That's what we are doing here today. Okay. After getting educated, we know programming languages. Okay. There's no point of doing this class, okay. So the whole reason to do this class to know programming languages. So that's why we are getting educated about programming languages. And then can Lamai we say computers to do the same thing? Okay, can we say to computers, okay, now I did my part, now I know programming languages, now it's your time, okay, please learn a programming language, then we can communicate. Can we say to our computers that? Right? No, Lamai. So even we, as I explained earlier, if you have a washing machine, and if I say to my washing machine, okay, now we have brought you, please collect all the dirty clothes, and it's your time to clean all the clothes. Will washing machine do that, Lamai? Right? No. So we have to do that for him. Okay, we have to do that. Okay? He's only going to do the washing part. Okay, we have to collect our dirty clothes and put into that, and press the correct buttons in the correct way, and let him to do that. Okay, we have to do that. The same way, Lamai, even though we are getting educated, okay, even though we learn programming languages, we can't say computer to learn programming languages. Okay, because he's not going to do that. He can't understand. Even though we say computers, okay, now it's your turn to learn programming languages, will he understand, Lamai? No, because computers can't understand natural languages. So even though we tell our computers to do that, he won't understand. Okay, that's the problem. Now what we can do here? Okay, what we can do here? Now we certainly know computers don't understand programming languages, and computers don't know human languages. But Lamai, what we can do here, and what people did here is they built another tool. Okay, now we have programming languages. After some studying, people can understand these programming languages. Okay, that part is clear. Okay, they created programming languages after studying some programming language, after spending some time on studying computer languages or programming languages. People can understand these programming languages, but computers can't do that. So what programming language engineers did? They built another tool called language translator. Okay, they built another tool called language translator. Okay, here we have language translators here. So let me erase this part and write in smaller letters. Programming languages. Okay, what they did is they built another tool called language translators. Language translators. In Sinhala, you call this what? Under the software classification part, you study this one. Okay, language translators. So in Sinhala, Bhasha Parivartaka. Okay, Bhasha Parivartaka or language translators. We built this tool, and then when now human know programming languages because they spend some time on getting educated. Programming languages. Now they know programming languages. Now they can write programs in using these programming languages. Okay. Now the language that we are going to learn in this class is Python. Okay. There are a number of programming languages. In our class, we are going to learn Python. Okay. We are going to learn Python. Now, after a couple of sessions, we will know Python. Then we can write programs in Python. But the thing is, still computers don't understand Python. What we can do, what we have done, we have built another tools called language translator. Now when we write some code using Python language, this language translator can translate whatever the program that we have written into a way that computers can understand. Okay, it was a very long sentence, right? Did you get that? Okay, did you get that, Lamai? Again, let me tell. Now what we have done, Lamai, we have built a tool called language translators, and we have a programming languages. Now, and also we have spent some time to learn programming languages. Now, since we know Python language, we can write some computer programs. Okay, we can write some computer programs, but still computers won't understand that. But we have this tool called language translator. Now, language translators can translate whatever the program that we have written in Python into a way that computers can understand. Okay, that's what language translators going to do. Okay, that's what language translators going to do. After writing some program in some language, then we can use language translator to translate whatever the program that human have written in programming languages into a computer understandable machine language. Okay, you get that part. Now, when it comes to language translators, okay, when it comes to language translators, we have different language translators. Okay, different types of language translator. Basically, in our syllabus, we study or we learn about 3 types of language translators. Okay, we specifically learn about 3 special types of language translators. The first one is Lamai. Now let me take this here, and from here I'm going to divide this into 3 parts again. Okay, we are going to learn about 3 language translator types, Lamai. Okay, the first one is I'll write here assembler. Okay. First one is assembler. Assembler is a kind of a very special language translator, Lamai, because it's going to translate this assembly language. Okay, there is a computer language line. We call this a low-level language because this most close to this much close to a computer processor. It's not very human readable language. This assembly language is not very human friendly language. It's much closer to computers. Okay, computers can easily understand this program after some translating. Okay, assembler will do that part for us, but it is not very human friendly. This assembly language is not very human friendly. Even though we read this program, we will not understand what's happening in that program properly. Okay, because it's much closer to programs or the computers rather than us. Okay, so what this assembler tool does is going to translate this assembly code into machine language. Okay, you understand that what this assembler does? Assembler do only one thing, is going to translate this assembly language into computer program or computer language, which is the machine language or 10. Okay, this will convert only assembly language into what? Assembly into machine language. Okay, assembly into machine language. That's what assembler does. This ML is not the machine learning. Okay, lamai. Nowadays you are familiar with those terms as well, lamai. Machine learning, artificial intelligence, GPT, LLM. Now kind of you are now these days you are also familiar with this stuff. Now if you see this ML, this is not here in this case. This is not machine learning. This is machine language. Okay, this ML. That's what assembler does. What assembler does is going to translate this assembly language into machine language, which is the 1 and 0. Okay, there are another two language translators. Okay, there are another two language translators. The next one I'm going to talk about is compiler. Okay, compiler. Let's write down the other one as well. The other one is lamai interpreter. Okay, interpreter. Now lamai, in some classes, in some other classes, maybe in schools, maybe in some other YouTube videos, you might learn now when people comparing these two components, like compiler and the interpreter, there are some false definitions in public. Okay, some people say compiler will translate the whole program into a machine language, and other people say interpreter is going to translate this language line by line. Okay, sometimes you will hear that explanation in some other sources as well, but most of them are incorrect. Okay, most of them are incorrect because I can't claim that publicly, because in university for my final year project as well as my research, what I did was I was doing programming language development. Okay, we developed some programming language for my final year project, which is called Simply, which can use which is more suitable for students from grade 6 to grade 11, which is more suitable for, and they can use any language, any natural language they want to use. Human language, like if they want to use singular letters, they can use singular letters. If they want to use Tamil letters, then they can use Tamil letters. If they want to write codes in Japanese letters, then they can use Japanese letters, whatever letters that they can use. Okay, then it will translate into another language called Java. Some might have heard the language called Java, and it will be executed in the Java-like environment. And we build that programming language, as well as when I'm doing my first job as a software engineer, I worked in IFS. And in the IFS core team I work. Okay, they are the people who are building IFS. It's one of the most popular and one of the biggest company in the Sri Lanka right now, Lamai, and they having their internal programming languages, which are not publicly used programming languages. Only those programming languages are used inside the IFS company. Okay, we call those are DLS, DSL, domain specific languages. Only the IFS people can use that language, because there is no purpose of using that language outside of the IFS. Okay, because the libraries and other stuffs, or the ecosystem within the IFS, so people outside the IFS, there's no point of using those languages. We call those are domain specific languages. And I was a part of the language building team, or the compiler team. I was a part of that particular team as well. So I did my first couple of years in compile engineering job. So I have that right to claim that, because when I see people are explaining these to students, there are most of them are incorrect. Okay, most of them are incorrect, but there are some people who are telling the correct thing, but it's very rare. Okay, it's very rare who are explaining this correctly. Okay? This is very general knowledge. This is very general knowledge. Everyone should know that, but the way people teaching this is kind of incorrect. Okay, now today you are going to learn the correct definition for these two things. Okay, so already you might have learned the correct definition, but here I can make sure, I can claim that you are going to learn the correct definition. Okay, now my compiler and the interpreter. Now you already know what assembler does. What assembler does is it's going to translate this assembly code into machine language. You know that part now. Okay, now what compiler does? Now when we write a program using some programming language, we call that the source program or a source code. Okay, like let's say when humans write some program using programming language, like let's say where I should draw this. If I use this area, it's also visible, right? Okay, now let's say the problem is there is a table here. Okay, I can't move to my left, but let's try. Okay, now we create some program using some programming language. Okay, some programming language, like let's say we have written this in. If I write there, it's not visible, right? It's not visible. So let me write it here. So let's say we have write this using Python. Okay, so now we call this source code. Okay, we call this source code. Like writing the Python here is not very not completely correct, because we are going to learn about compilation in some programming language. Okay, some programming language. Okay, we have write this code. We call this a source code. Okay, we call this the source code. Now this is the program that people have written using some programming language. Okay, using some programming language, people have write this code. We call that a source code. Now this source code or the source program might contain couple of files. Okay, may contain couple of files, or that might be a single file or couple of files. Okay, whatever. So we will learn those things later when we are learning Python. We can learn those things in depth, but right now just try to understand this. Might be a couple of files, so single file, but right now in order to understand this compiler and interpreter, let's say this is only a one file. Okay, only a single file. We have written our code in a single file. Okay, now what compiler does is compiler will convert the whole program into some target language. Okay, here let's say machine language. There are some other examples. Compilers not compile or translate this into machine language. Okay, it will not directly compile this into machine language. It will it might translate this into some intermediate languages. Like when it comes to Java language, Java compiler will translate this source program or the Java code into another language called Java bytecode. Okay, it's a intermediate language. Okay, then some interpreter is going to execute that code. You don't need to learn those things here. Okay, when it's come to programming languages like C language, then C compiler will translate this code into directly machine code. Okay, then operating system can execute that. Okay, so likewise, like let's say some target code. Okay, target program. This is the source program. This is the target program. But here I think using the target program word is not very sufficient, because you might be confused with this machine language thing. So okay, so here I'm using just the target code, not the target code, the machine code. Let's say machine lang. Okay, this is some program. This is in machine language. Okay, this is in machine language now. So this is the target program, source program to target program. Now what compiler does is it will convert or translate this whole program into machine language. Okay, it will convert this whole program into machine language. Now if we have a source program here, okay, let's just write down the definition. Just write down the definition. Translate, not the convert. Correct word is translate. Translate whole program into what? Into machine language. That's what compiler does. Okay, what compiler does is it will translate this whole program or the whole source code into machine language. Now tell me this now. Did this program get executed now? Okay. After compiling this, after compiler did this job, did this program get executed? Okay. Executed means kriyatmaka vena. Okay. Did this program get executed? Now we have this program here, and using compiler we translate this into a machine language. Now tell me, is this program get executed? No, Nilamai. Okay, got some answer. Let me. No, yeah, this program has not been executed yet. It just has translated into some another language. Lamai. In this case, it's machine language. Okay, what compiler does is it's only going to translate this source program into another program or another language. Okay, what compiler does is it's going to only translate our source code into a target code. In this scenario, it's going to translate our program or the source code into machine language. That's only what compiler does, Islam. It's just translating stuff. Okay, that's the whole responsibility of compiler. It's not going to execute anything. When we say a compiler do nothing but translating some code into machine language. Okay, only translation part, lamai. Only the translation part. Then the machine language or the final result that we get from the compiler, someone else can execute this one. Okay, basically when it comes to machine language, operating system and our processor is going to execute that code, lamai. Okay, collectively processor and the operating system going to execute that code. Okay, what compiler did is it's only translate this program from the source code to machine language. That's what compiler did. That's only what compiler do, lamai. Okay, it's just translating things. It's not going to execute our code. Okay. Now what interpreter do? Okay, what's the responsibility of interpreter? Okay, now lamai, this is what interpreter is going to do. Okay, this is what interpreter going to do. Now let's say in our source code or the source program, we are having some instructions in lamai. Now these instructions are written in which language? These instructions are written in programming languages. Okay, using some programming languages, we have write our program. Okay, we have write our program using what? Some programming language. What interpreter do is, lamai, I think it's better if I draw this here, then I have enough space to draw the whole story, lamai. Okay, I will write the explanation of program here. Okay, now we have some program, okay, which is written in some programming language. Okay, using some PL. Okay, PL means programming language, lamai. Okay, PL means programming language. Now I have write some program using programming language. What's interpreter going to do is, lamai, now when in this program, okay, in this program we have set of instructions, lamai. In this program also we have a number of instructions written down in a file using some programming language. Okay, now what interpreter going to do is it's taking one instruction by instruction. Okay, we can say line by line, which is not completely correct, but for here only for understand. Okay, to understand, lamai, let's say line by line. Okay, what interpreter going to do is he get this first line. Okay, get this first line, then interpreter will translate only that line into machine code or the machine language. Okay, what interpreter do? Get the first line and then translate it into machine language. Only the first line, lamai. Okay, only the first line. Here interpreter, okay, what he do is interpreter translate that into, okay, translate that line into machine language. Okay, translate that into machine language. Only one line, lamai. Okay, interpreter translate. Okay, first interpreter will translate that one line, only one line, into machine language, but interpreter not stops there, lamai. Okay, that's not the only what interpreter does. Then what interpreter going to do, lamai, he will execute this part, the only line he converted into machine language, then interpreter will execute this, lamai. Okay, actually when the interpreter working, lamai, or Python like interpreter, this is not machine language, lamai. Okay, that's the first thing that we have to understand. This is not machine language, this is some intermediate language, but in A level syllabus, lamai, we can't explain everything. Okay, that's the problem that we are having here, because you don't have very clear understanding about programming languages, lamai. We get only a couple of like 60-70 periods to teach all the Python stuff. Because of that we can't teach everything, but we have to understand up to some level, lamai. Okay, what interpreter does is first is translate this code into machine language, then he will execute this, lamai. Okay, then what interpreter going to do is, then it will execute, not only converting this language into machine language, this source code into machine language line by line, it will execute this instruction as well. Okay, that's the difference between compiler and interpreter. Compiler will only translate your program from source code or a higher level language to machine language. That's the only responsibility of the translator or a compiler. The compiler will only translate your source code into machine language, but what in the and the whole program, compiler will translate your whole program from some high level language to machine language. Okay, like programming language like Java will convert whole program, like C, language like C will convert whole language, whole program into a machine language. Okay, that's what compiler do. But interpreter do these three steps, these two steps, line by line. Okay, line by line is not completely correct, but here only for understanding I will use that line by line part. Okay, what interpreter going to do is, he will take line by line. Okay, in the same way that fetch, decode, execute cycle work. Okay, the same way fetch, decode, execute cycle work. That's what interpreter does. Okay, now our processor is nothing but a hardware interpreter. Okay, that's the beauty. Okay, our processor is nothing but a hardware interpreter. Now this interpreter is a software interpreter. Okay, our processor will do the same thing in using some hardware. Okay. But in our interpreter, it's a software. It's a software. Okay, you will take you have to go to university and learn compile engineering stuff in order to understand these things very clearly. Only then you will understand this. Now I'm not sure you are understanding any of these, but just remember those things. Okay, just remember those things. Only after taking some compile engineering lectures, you will understand those things. Okay, now what interpreter going to do is, he will take line by line and then convert into some machine language, and then interpreter itself will execute this code. Then he will take the next line, translate into machine language and execute. Then take the next line, translate it into machine language and then execute. Get the next line. Until program ends, interpreter going to execute this whole program. Okay, until this program ends, interpreter will execute this program, not only translate, but also it's going to execute this program. But it will be done in a line by line manner. Okay, it will be done in a line by line manner. Take the first line, translate into machine language, execute. Take the next line, translate into machine language, then execute. Take the third line, translate into machine language, then execute. That's the way the interpreter going to work. That's the way that the interpreter going to work. But compiler do not execute our programs. Okay, remember that. Compiler is not going to execute our codes. The only thing that compiler is going to do is translate our programs from one language to another language. Okay, translate our programs into one language to another language. That's what compiler is doing. Okay, that's what compiler is going to do. But interpreter not only translating our program line by line, but also executing our program. Okay, that's the beauty. That's the difference between our interpreter and the compiler. Okay, raise your hand if you understood this part. Raise your hand if you understood up to here. If the whole story is clear to you, please raise your hand. Superb. Others? Okay. You might either understood everything, either didn't understand anything. I don't see any middle ground that you can stay this level. Okay. Okay, Lamai. So if there are any questions, please put in the chat, Lamai. Okay. If there are any questions right now, if you have any questions, please put in the chat. I'm going to answer the questions that you have up to here. And if you don't have any questions, let's take some notes. Okay, that's what we are going to do. So can you explain compiler part? Okay, sure, I will do that again. Now what the compiler going to do is, now when we write some code, we have some codes after writing using a programming language, we might have some codes. What compiler going to do is only translate this program. Okay, now this program, let's say this program is written in language like C language. Okay, C or a Java, whatever programming language that we have used. Now this program has been written in some programming language that people can understand. Then what compiler going to do is convert whole program into machine language, that means 1 and 0. Then computer understand that program. Then what's going to happen? According to the fetch decode execute cycle that inside our computer, then that program will be executed. Now after compiler translating this program into machine language, then we will have this one set of instruction which is written in a computer understandable way, which is written in a way that computers can understand. Then CPU can execute this code. What is the way that CPU going to execute this code? It will fetch these instructions one by one. Now these instructions are in a machine language which CPU can understand. Okay, because our compiler have already converted this language or source code into some machine language. Now when we have some language now code, like let's say now if I'm using language like C or let's say Java. Now if I'm writing something in Java, in order to print something into our screen, I have to write something like this. Okay, like let's say class main, and we get some curly brackets here, and inside this I have to write the main method, public static and void main. I'm having some arguments here, and inside here I will write system dot out dot println, and inside here I'm going to write hello world. Okay, now this is a Java code that I have written to print hello world word into the screen. Okay, you can't see the most you can't see the final 2 lines, but those are only curly brackets. Okay, it's only 2 curly brackets. But when I write this code in Java language. Now our processor, okay, our processor can't understand any of this. That's the problem. But human can understand this. Why? As human, we have spent some time to learn Java. Now myself, I know Java. Okay, I have spent some time to learn Java. I know this, but computer don't know this. Computer can't understand this. What I have written here, computer can't understand. So if I want to execute this program inside the computer, what I have to do? I have to convert this into a way that computers can understand. When I say computer, that's CPU. Because CPU is going to execute our codes. CPU is going to execute instructions. Okay, so I have to convert this program in a way that CPUs can understand. But I can't do that. But engineers have built some tools called language translator. Now, one example for that language translator is compiler. Now, what compiler going to do? He will translate this whole program. He will translate this whole program into machine language. Now, in the exact scenario, that's the problem when I'm teaching. I'm also a software engineer. So, when I'm teaching some things, I want to make them understandable to you, as well as I have the fear if some of my friends watch from the office, if they watch this video, they will ask me, they will say like that. So that I have this dilemma. Okay, I have to make sure that you understand these things, as well as I'm not telling any lies to you. Okay, I have that problem, but let's try to understand. Okay, let's assume, okay, if someone watched this from our company, okay, this is not entirely correct. I know that, and just don't okay, tell my lead engineers that these buggers don't know programming languages either. Okay, just don't do that. So okay, this is only to A-level students. Okay, now what we are going to do, what compiler going to do, not P, what compiler going to do? He will translate whole program into machine language. Okay, he will translate this whole program into machine language. Then when it's compiled into machine language or translated into machine language, our CPU can understand these instructions. Okay, then he can execute this instruction one by one using fetch decode execute cycle. Using fetch decode execute cycle, CPU can execute this program. But here at this level, my computers can't understand, or the CPU can't understand any of this. Okay? CPU can't understand any of these. But as human, we can understand. Why? We have educated. Okay, we have spent some time on education. We have spent some time to learn Java, but computer haven't done that. So what we have to do? We have to translate this into a computer understandable language. So compiler, what compiler do is compiler translate this whole program once. Okay, whole program into machine language. Okay, what's compiler going to do is he will convert this whole program into machine language, then processor or the CPU going to execute this program. Okay, that's what compiler do. It's not execute. Compiler do not execute our program. Okay, do not compiler execute our program. But when it's come to interpreter, interpreter not only translating line by line but also executing the program. That's the difference between compiler and the interpreter. Okay, I think it's Zahim. Pula, did you get that? Please raise your hand if you understand that. Pula. If you understand that part, please raise your hand. Yeah, super. Okay, then I have another question. Sir, where does the compiler stores the compiled code? Now, good question, Lamai. Good question, Pata. Now, it's depends on the programming languages, Lamai. Okay, depends on the programming languages. But when it's come to languages like C, when we are using the compiler, now we tell our compiler to execute. No, the compile that code, Lamai. Okay, when we write a code in our computer, compile is not going to think like, okay, now this bug has finished writing the code. It's my time to compile this code. No, compiler not going to do that. Okay, we have to tell compiler, okay, now I am done with writing code. Please compile this code for me. I have to tell compiler. And when I'm telling that, I can tell compiler, okay, where you should store the target code. Okay, I can tell compiler. Okay, I can tell my compiler, okay, where you should store the target code. That depends on the programming languages. Sometimes some compilers will store in the same place as the source code. Okay, let's say I have a folder called ABC, and inside that ABC folder I have my program. Okay, abc.java. Let's say. Okay, let's imagine abc.java. When we tell our compilers to compile our code, compiler will store sometimes maybe in the same place. In other cases, I can tell my compiler where you should store the target code. Okay, where I should store the target code. I can tell my compiler. Okay, that's how compilers are built, Ramai. If I don't mention, most of the time the target code will be stored in the same place as the source code. It depends. Okay, so it depends on the ecosystem or the programming language that we are using, the compiler version that we are using. It depends. Okay. When it's come to A-level syllabus, we don't have to worry about that because no any target code is going to be generated, because interpreter is not generating any target code. Okay, interpreters are not generating any target code. It's execute the code actually. Okay, interpreters execute our code first. Before execute, it will convert this language line by line into machine language. Convert the first line, then execute that line. Convert the second line, and then execute that second line. Convert the third line, and then execute. So since we execute on our program, there won't be any generated target language, target code. Okay, because it's do the executing part as well. Now, when we are using compilers, compiler only translate the code. So there should be some output code line which CPU can execute. Okay, there should be some output code which CPU can execute. Okay, that's what compilers do. Okay, I think you understand the whole picture. Now, do you have any other questions, Lamai? If you have any other questions, I can answer. And if you don't have any questions, I think it's better to take some time to take this note. Okay. Now, Lamai, when it's come to taking notes, you have to remember this. When I'm teaching in single medium classes also, for any batch, I'm not giving a single line of notes, Lamai. I'm not going to give notes. Okay. Students should be able to take notes, Lamai. Okay. Students should be able to take notes. I have seen in a number of classes, Lamai, teachers are nowadays providing what? A number of tunes and resources they are providing. Students don't do anything themselves. Okay, that's one reason why students can't understand or remember these theoretical concepts well. They can only do the calculations. Okay, it's nothing that if you can do only the calculations, you are nothing but a monkey in a circus. Okay, you don't know any theoretical stuff. You don't understand these theoretical parts very well, but you can do calculations. Okay, when you get a logic gate question, you can write the expression. You can simplify that using K-map or whatever the rules that we have in Boolean algebra, and then you can draw the logic circuit, and you can draw the same logic circuit in universal logic gates. You are trained to do that. If you don't understand why these logic gates are there, what are these logic gates actually doing, how these things are happening, if you don't understand the philosophy behind these things, you are nothing but a monkey in a circus. Okay, nowadays monkeys that in a circus, they can do many stuff. They can jiggle balls and they can go in wires, and they can do a lot of very advanced stuff even people can't do. Okay, so if you are only doing those calculations, then you are only a monkey in a circus. So don't be that student. You should take your notes. Okay, that's what I believe. You should take your notes. I should help. The only thing that I'm going to do is I'm going to help you with these things. Please take a note to yourself. Please take a note to yourself. Starting from here. Okay, now the first thing that you are going to do is first thing that you should do, try to understand this part. What's the program? Okay, what's the program? That's the first thing that you have should put into your notebook. What's the program? First, let's understand what's a human program. Okay, program is nothing but set of instruction. When it's come to a McDonald's packet, there is a program. Now, who is going to execute this program? Okay, human, people. Now, we are the interpreter for this. Okay, we are the interpreter for this. Now, they have write these instructions in human readable language. We read the instruction and we execute. We read the next instruction, we execute. We read the next instruction and we execute that. We are working, we act like the interpreter. When we are preparing a McDonald's packet for our dinner, we are acting as an interpreter, human interpreter. We will execute all the instructions written in the McDonald's packet. Okay, this is a human program. Take that part first, and then try to understand what's the computer program. Okay? Now, human program is set of instruction which is written in a way that human can understand. Computer programs is nothing but a set of instruction which is written in a way that computers can understand. Right? That's the difference. Now, this is an example for a computer program. Now, basically, when it's come to a computer readable programming language or a program, it should be 1 and 0s. But here, when it is in 1 and 0s, we can't see anything. Okay? We can't see anything. So, what we do, we come one level higher. Okay, and we have this abstract language, which is assembly language. We try to understand our programs in this way. Now, this abstract language, not actual abstract language, this existing language. We have this assembly language, but this is not understandable for people, but computers can understand this. Okay, computers can understand this. So then we come to this scenario. If people want to build software programs, if people want to build programs, they should know about computer languages. They should know the language that computers can understand, which is the machine language. But the problem is people don't know. When it comes to computers, when you think about the computers, they also don't know the language that people speak, or the machine or the natural languages. So what we decided? We decided to create another language and both parties don't know. Okay? Which both parties don't know, we create another language called programming language, but we can come to this middle ground now. Now, since we have a middle ground, we can use some workaround to make this scenario possible. So what people can do in order to understand programming language, they can get educated. Okay, they can spend some time to study this language. But computers themselves, they can't understand this after spending some time on education. So we have to make that happen. Okay, so what people did, they built some tool called language translators. Now, when we write some code using programming languages, still computers can't understand these programming languages. Still computers can't understand. But if we want to execute this program inside a computer, we have to translate this language, this code, into a computer understandable way. Okay, for that particular task, we build some tool called language translators. And there are 3 types of language translators that we are learning in our syllabus, A-level syllabus. Okay, what are these 3 language translators? The first one is assembler. Okay, what assembler do? It's only going to convert assembly language into machine language. Okay, that's the whole responsibility of assembler. Assembler will convert our assembly language into machine language. Now, what compiler does? The job of the compiler is when we write some program using some programming language, the responsibility of compiler is translate this whole source code into machine language. Then processor or the CPU can execute this program. Okay. Job of the compiler is translate the whole source code into machine language. Then our CPU can execute this code. CPU can execute that code. What interpreter do? When we are using an interpreter, and when we have some code, like let's say in Python, we have write some program using Python. What Python interpreter going to do? It will take line by line. Okay, it will take line by line take one line, convert into machine language, then execute. Take the second line, convert into machine language, and then execute. Okay, this part, this whole image lamai, you have to understand that part. You have to have better idea about this part. Then only we can understand programming languages lamai. Otherwise, we are just writing some codes. We don't know anything what's happening inside our computer. We don't know anything. We are just writing codes. Okay, that's not good lamai. Okay, that's not good. You have to understand what's actually happening behind the scenes. What's actually happening. Then only you understand programming languages. Okay, then only you will understand. You will become better programmers lamai. Okay, then only you will become better programmers, so better software engineers. I think your target to become software engineers, I believe that. Okay, I'm not sure what's your idea of doing ICT. Okay, it might be because of ICT increasing your ICT score. It might be that might be the reason. That's also a valid reason, lamai. Okay, that's also a valid reason. But yeah, I believe when some students select ICT for their A levels, I believe that they want to become software engineers in some day, lamai. Okay, I believe that. Okay, yeah, that's all about that. Yeah, that's how you should take this note, lamai. Okay, shall we take some time to take this note, lamai? Okay, I'll give you a couple of minutes. Please take this note, and when you finish, please put a chat, lamai, on the chat. Meantime, if you have any questions, please ask in the chat, lamai. I'm going to mute myself, and please take like couple of minutes to take this note. Okay. Lamai, please raise your hand if you are done. Take this note. If you are finished taking this note, please raise your hand, Lamai. Okay, we have one hand. So what about others? Okay, we have two hands. Dishan, what are you done? Okay, super. Everyone has finished taking note. So I think we can clear the board. I have very beautiful note here. Don't like to clear this, so I think you have finished taking notes, right? So anyway, let's clear the whiteboard. Okay, super. I will clean this part as well now. Since you know this is the programming class, I clean that part as well. Okay, super. Now Lama, you have a basic understanding about what is a programming language, how programming languages are working, why actually we build programming languages. Now, why actually Lama, we build programming languages? Why people build programming languages like C, Python, Java, C++, C Sharp? There are a number of programming languages there, Lama. Why people build those programming languages? The thing is, the real answer is to make building softwares easier, to make developing softwares easier, to make the process of developing softwares easier, to also bring that knowledge to the general community. Okay. Otherwise, back in the days where people know only the machine language, the machine when only machine languages exist, only few people knew how to write programming languages, programming programs. Okay. When there was no any programming languages, when they are existing only machine language or 1 and 0, only few people in the whole world, okay, only few people in the whole world know how to build some softwares, right? To bring that capability to the general community, or to make that much more familiar with the familiar with other peoples. That's why they had to build programming languages. Okay, then we can use some we can get educated to write programming, to know those programming languages, and they build some other tools to translate, to make those codes that people have written using the programming language to understandable to computers. Okay, so we call those language translators, and we know a couple of steps about those things. And yeah, so to be honest, that's what I wanted to teach you today. And from the next week, or from the next episode, what we are going to do is we are going to learn Python, Lamai. Okay, from the next episode we are going to learn Python. So when I'm teaching Python, Lamai, and this is not kind of the general way that we are learning programming language. So if you watch YouTube channels, other teachers are also doing Python classes free nowadays. But I'm not starting with drawing flowcharts and stuffs like that, which is very boring. Okay, which is boring. I'm not going to do that. Let's start directly from Python, and when we are getting familiar with the Python, and when we write in some advanced codes, we eventually start, or we will begin to write some draw some flowcharts according to that. So just stick with my process if you are really willing to learn from me. Okay. And next thing, Lamai, from the next episode, I will not use in this whiteboard environment. I will using the screen share environment. Okay, and I will write all the codes in the computer. I'm not write any codes on the whiteboard from this episode, Lamai, because that's not the proper way to learn programming. Only if I want to draw something, I will use in the screen whiteboard, the whiteboard software that I'm having in my computer. We will not use in this whiteboard environment anymore. And the next thing is the second lesson, the hardware lesson, which is a very important lesson in our syllabus. So basically, when I'm starting a revision, maybe a revision class, whatever theory class, whatever that I'm starting, first thing that I teach them is the second lesson, okay, computer architecture. That's where we learn how our computers are working. Then only we can understand our computers, in A-level syllabus. Okay, in A-level syllabus, most of the lessons that we are having 13 lessons, among these 13 lessons, almost like 8 to 9 lessons that we are studying to learn our computer, to learn our computer, how our computer works. The second lesson is the where we learn how actually computer hardwares are working. Okay, how actual computer hardwares are working. If we can't understand the hardware layer, then it's become difficult to learn operating system layer. That's the next abstraction layer that we are having. Okay, above the operating system layer, we are having our programming languages that we are learning in this programming lesson. If you don't understand the hardware layer, then there is no point of learning other abstractions. Okay? We have to have a better understanding how our hardware are working. If only when we know actually how our hardwares are working together to accomplish some task, then only we can understand why there is such a thing called 2's complement. Okay, only when we know about our computer, we know why there is such a thing called 2's complement or IEEE 745 representation. Okay, then only we can understand what's this 8-bit computer. When we are working with 2's complement mathematics, we always say like in a 8-bit computer, okay, in a 16-bit computer, most of the time we hear that 8-bit computer word. So in order to understand what is this 8-bit computer, first we have to have some idea what is this first 8-bit computer. Okay, if we now, most of the among A-level students, they know how to calculate that 2's complement calculation. Okay, they know how to do the mathematics part, but they don't know what they are doing. Okay, they just don't know. But if you understand that part, if you have a clear image about that part, then writing this, doing this calculation becomes very easier for you. So otherwise, you have to remember everything. Yeah, what are the steps? What are the steps that you have to follow in order to do this 2's complement calculation? You have to understand. You have to understand these things, If you know your computer, then you can do those calculations properly. And when it comes to the logic gates lesson, there are some advanced logic circuits you are learning at the end of the logic gate lesson. First one is the full adder. Okay, now full adder is the component which is going to that when you are using that 2's complement calculation. At the end, you add those 2's complement numbers in order to get some subtraction result of subtraction. You will add those two numbers. Now full adder is the circuit who is actually going to execute that task. Okay, full adder is the circuit. Now where is your full adder? Full adder belongs to the ALU of our CPU. Okay, full adder belongs to the ALU of our CPU. You learn about the CPU in the second lesson. Okay, now how computer knows that ALU is the component which should be triggered for this particular instruction. Okay, when CPU fetch instruction, it's going to decode our instruction. Then he know what is the operator and operator. Okay, what is the operand? What are the operands and what is the operator? If he sees the operator, okay, now operator is the addition or the sum, then he will going to pass these two operands to full adder. If it is the subtraction, then he will first pass the first part into the 2's complement circuit, then the result will be passed into the full adder circuit. That's how our computers are working, These all lessons are connected together. At least first 5 lessons. Okay, not the first lesson. First lesson we just learn a few. We are trying to get some high-level idea about what is the IT industry. Okay, not the first lesson, but second one, the hardware lesson, number system lesson, logic gate lesson, and then operating system lesson, then Python. These lessons are tightly coupled, These lessons are tightly coupled. If we don't understand the second lesson, we don't understand other lessons as well. Okay, so if you are interested, if you are interested, I can go through in some separate sessions. I can go through these parts as well. Okay, only if you are interested, I can go through these parts as well. So I'm not sure all of you are in the group chat yet. So there is a WhatsApp chat lamai. Okay, there is a WhatsApp chat. I will okay, let me send that link here lamai. So if you are not joined yet, please join now. Let me send this to you. Okay, now I am putting this on the in the Zoom chat lamai. So if you are not joined this chat yet, please join. I will put this chat link in the YouTube video as well for the people who are watching this video in the YouTube chat, YouTube video. So I will put this link in the description. Please join the WhatsApp chat, and then here there we can start some conversation there. Okay, what are the lessons that you want to learn in separate videos? We can have that conversation there. Please join if you are not already joined the WhatsApp chat. And yeah, also learning about the computer memory. There are 4 parts in second lesson, which is the hardware lesson. First one is history, second part is actual hardware, third one is von Neumann architecture, and the fourth one is computer memory. You have to have a better understand about all 4 components. Okay, all 4 parts of the second lesson. Then only you will actually understand what is in the second lesson, the third lesson, which is number system, logic gates, and the operating system, and same in the programming lesson. Okay, so you have to have a better understanding about the second lesson, which is the computer architecture, the computer organization lesson. Okay, you have to have a better idea about those parts. So if you are interested, then we can do do those things in a separate session. Okay, so please send me a chat, and from the next week or the next episode, we will do our class in a shared screen session. And lamai, if you have any friends, okay, if you have any friends who's doing the ICT in English medium, please invite them to this group, and please send the Zoom, please share the Zoom link with them as well. Okay, because this is going to be a free session. Okay, after finishing the Python, I will move into database, and after finishing the database, also I will do the web sessions as well. So I think this is more suitable for 2025 students. If you are 2024 student, then it's okay, but I'm not sure whether I can finish all these 3 lessons before November, before your A levels. I'm not sure I can finish everything, because I'm taking a long time to teach these things. Okay, now if you watch the singular YouTube videos that I'm doing in Python, we do 3-hour class every day, and now we are in the 10th week. Still we are not even have come to the if else part, because we have to take some time in order to understand these things. Now I can take some time just to let you know how to write some Python codes and let you write some codes. This is nothing but making a monkey in a circus. Okay, I don't like that part. So this is more suitable. This is going to be more suitable for 2025 students. If you are 2024, then you can watch these videos, but I'm not sure I can finish this before November. Okay, that's the only concern that I'm having right now for the 2024 student. But for the 2025 student, this is the ideal place to learn programming languages and other practical lessons in the entrance. So if you know any English medium students who will write their levels in 2024 or 2025, please invite them to the chat, and please share the Zoom link with them. And now that's all for today. Do you have any questions? Anyone have any questions, Lamai? Okay. Anyone have any questions? Okay, seems not. So Lamai, that's all for today, and we can wind up the session for today. And thank you so much for joining, and let's meet in the next session, Lamai. Okay, next session is on next what is today, Lamai? It's Thursday, right? Okay, next session is on next Thursday, 7 p.m. to, let's try 9 to 10, like, okay, let's do. Okay, let's see what's the possible. Okay, again, Lamai, thank you for joining, and good night. Okay, let's see you in the next session.